Imagine a world where the buzzing of bees has faded into silence, rivers run lifeless, and fertile soils turn barren, not from natural disaster, but from the very chemicals meant to protect our crops. Pesticides, hailed as agricultural saviors, are silently scripting an ecological apocalypse, accelerating climate change while decimating biodiversity. The truth? We are poisoning our planet to feed it. They were created as a solution, a way to protect crops from insects, weeds, and diseases. They promised more food, healthier plants, and higher yields. And in many ways, they delivered. But there's a part of the story that's often left out, a hidden side effect with global consequences. Pesticides don't just kill pests, they can also heat up our planet. And their role in climate change is much bigger than most people think. Pesticides are chemicals, sometimes synthetic, sometimes derived from natural sources, designed to target unwanted organisms. There are insecticides for insects, herbicides for weeds, fungicides for molds and fungi. In modern agriculture, they're everywhere. More than 4 million tons of pesticides are used globally each year. From massive industrial farms to small local fields, spraying has become routine. But here's the problem. Every stage of a pesticide's life cycle, from factory production to spraying, to its breakdown in soil and water, can affect the climate. Some pesticides release greenhouse gases directly, others harm ecosystems that normally store carbon, and some set off feedback loops that lead to even more chemical use. The story starts in the factory. Making pesticides is extremely energy intensive. The chemical reactions needed to create them rely heavily on fossil fuels. Studies show that for every kilogram of active pesticide ingredient produced, 5 to 10 kilograms of carbon dioxide equivalents are released. That's just the manufacturing stage, before transportation, storage, or application even begin. Then comes the application phase. Spraying pesticides usually involves tractors, irrigation pumps, or even airplanes, all of which burn fuel and emit carbon dioxide. And then there's what happens after pesticides hit the environment. Some release nitrous oxide, or dinitrogen monoxide, a greenhouse gas that is 310 times more potent than carbon dioxide at trapping heat. Others disrupt soil microbes that normally help break down methane, another powerful greenhouse gas. When these microbes die, methane stays in the atmosphere longer, adding to warming. Healthy soil is one of our greatest allies in the fight against climate change. It's like a giant underground vault, storing carbon for decades or even centuries. But pesticides damage this system. They harm beneficial organisms, mycorrhizal fungi, earthworms, and bacteria, that are essential for soil health and carbon storage. When these communities collapse, the soil loses its ability to lock away carbon. Instead, that carbon escapes into the air as carbon dioxide. Herbicides add another layer of harm. By killing plants, they reduce photosynthesis, the process plants use to pull carbon dioxide out of the air and turn it into oxygen and biomass. Fewer plants mean less carbon absorption. It's that simple. Pesticides don't only affect the targeted pests. Their effects ripple across entire ecosystems. In water, pesticide runoff kills phytoplankton, tiny floating plants that produce about half of the oxygen we breathe and capture massive amounts of carbon dioxide. When phytoplankton populations drop, the planet's ability to store carbon drops with them. On land, the story is just as troubling. Neonicotinoid pesticides have caused bee populations to decline by 29 to 36% every year in some regions. Without bees and other pollinators, crops and wild plants can't reproduce as effectively, which means fewer plants to store carbon and support biodiversity. Birds, too, are affected. Many species that naturally control insect populations have been poisoned by pesticide exposure. With fewer birds, pest populations explode, and farmers often respond by using even more pesticides, creating a dangerous cycle. And here's where the story gets even more complicated. Climate change itself is making pests worse. Rising temperatures allow insects, weeds, and plant diseases to expand into new areas. In some cases, they survive through winters that used to kill them. Farmers, facing these new threats, respond by spraying more often or using stronger chemicals. But this extra pesticide use releases more greenhouse gases, damages more ecosystems, and further weakens the natural defenses that keep pests in check. It's a feedback loop, and every turn of the cycle speeds up climate change. In India, for example, excessive pesticide use has degraded 30% of the country's arable land. This means poorer soil, lower fertility, and more reliance on chemical inputs. The result is not just a local farming crisis, it's a source of greenhouse gas emissions that affects the whole planet. Globally, some pesticides linger in soil and water for years. They spread through food chains, weaken ecosystems, and make climate change harder to fight. The good news? We have options. Biopesticides made from plants like neem are biodegradable, effective, and far less harmful to the climate. Integrated Pest Management, or IPM, combines natural pest control, crop rotation, and targeted spraying, cutting chemical use by up to half without sacrificing yields. Precision agriculture uses drones and sensors to deliver pesticides only where needed, reducing waste and emissions. And on a larger scale, governments can support farmers with organic farming subsidies, carbon credits, and strict limits on high-impact pesticides. Each of these steps chips away at the climate impact of agriculture and protects the ecosystems we depend on. Pesticides were meant to protect us from nature's threats, but in many ways, they've become one themselves. If we change how we farm, we can protect our soils, restore biodiversity, and slow the warming of our planet. Because feeding the world should never mean heating the world. If you found this video insightful, hit like and subscribe so you don't miss our next deep dive. Are neonicotinoids really killing the bees? We'll unpack the real science behind the global bans, the alternatives, and what it means for the future of farming and pollinators. See you in the next one.